Hello, everybody, to our today's webinar together with Square Paper. We are very happy to welcome you and give you a deeper insight in the product offering of Square Paper today. With me together, I have John and Spencer from the Square Paper team, and I would like to hand over them directly. Just one information for you: if you have any question at any time, you could use the chat in your panel to send us the questions, and we will then answer them at the end. John and Spencer, are you there? Are you around?
Hello, yes. Yes, we're here.
Perfect. So I will hand over my screen to you, and it's your turn. Thank you for being with us.
Well, hello everyone, and good afternoon. We're going to split this into two parts. The first part, we're going to explain the why we've made what we've made, and talk a little bit about some of the issues with microservice architectures and enterprise service buses. And the second part will show you an example of a real-life type of system and how that's put together. We'll try and keep it very short, and obviously if anyone wants to go through any of this in more detail or look at other examples, we'd be happy to communicate with you afterwards. So the first thing is what problem were we trying to solve? And this particularly from the in the sort of broadcast and media industries. We've ended up with a lot of different systems, and the systems all deal with parts of the workflow. So you might have in your plant a media management system, maybe several media management systems, playout automation, scheduling system or scheduling systems often, a web CMS, and many other small systems that deal with parts of your workflows. Attempts to kind of join those together usually involve point-to-point communication, either using drop folders with files or ad hoc protocols between pairs of things. But obviously, as the number of systems grows, you end up with a big intercommunication cross-product. So, you know, if you've got 10 systems that have to all intercommunicate, you've got 100 different links to deal with. Also, the thing that we observed in most of the customers we talked to was that the system intercommunication was always incomplete. Although it was possible to do, it never got finished, and they ended up with many ad hoc processes with people performing tasks that could be performed by systems. So an example of that is where you have client managers who are constantly being called by a customer to ask if something's ready or if something's available, that kind of thing. And those staff then poll the operational staff to say, can you give me a report on that? Can you tell me that? The other thing that's proliferated is the use of spreadsheets as blackboards for communicating between departments or between data, usually the Google Docs type of spreadsheet, where lots of people just use that as a way of intercommunicating. Of course, the problem with those kind of things is there's no proper audit trail. It's difficult to work out who did what when, and when things go wrong, they go wrong badly. The other big driver that meant some change was needed was that this business cycle has got faster and faster. So the traditional sort of way of doing a system was to specify it, then go out to tender, procure something, then the manufacturer or the nominated contractor has to build it. You then have to debug it, integrate it, train staff, and deploy. That cycle can never be completed in less than 6 months, and usually by the time 6 months gone by, the requirement has changed. And so the traditional approach was starting to fail. About the same time we were looking at this, a lot of people started using microservice architectures. And you know, at the risk of sort of telling you things you already know, this is just the Wikipedia definition of a microservice architecture. But a microservice architecture really is taking an application or a set of applications and constructing them using lots of small services. The idea being that each service does one tiny part of the process, has defined inputs, defined outputs, and does that well. And those services can be independently coded. They don't have to be all using the same computer language. And particularly the persistence, when I say persistence, this is how something stores information that it's going to keep for a long time, over, say, a reboot, for example, like a database. And there was an approach, maybe, of the large monolithic systems where you try to put everything into one big database. That's the opposite of what you do in a microservice architecture. So in a microservice architecture, you say anything that needs to remember something, it can have its own little database and it can remember it. And if it, for example, is storing structured data, it could use an SQL database like CentOS. If it's storing unstructured data or data that needs to be searched, it could use, for example, Elasticsearch. If it's storing large amounts of data that need to be analyzed, it might use a different type of database. So like Cassandra, for example. So you use the appropriate tools at the appropriate places to do the job, and you don't worry about the trying to remove all the redundancy in the data. Hello, I'm sorry, I don't know what happened there. Where did we get to?
We got the last of your microservice architecture explanation, and then we lost you, unluckily.
Well, my apologies to everyone for that. I'm not sure what happened there, but we've now got a box on our screen that I don't know how to get rid of. I'll just move it out of the way.
No problem, you're back. Just
okay, we'll carry it. Yeah. The other thing that that microservice architectures using point-to-point protocols make quite difficult is the idea of asynchronous notifications, because they've largely been used to build websites, really complex websites. But in media and broadcast systems, we often have this idea of some external thing that changes. So, and things having to be notified of that. A classic example would be as events play out on air, they go from the future into the past, and that might need to be indicated to someone asynchronously. So you need a mechanism in your structure for having asynchronous notifications, and these are quite difficult to implement using point-to-point protocols. Another idea that's around is the Enterprise Service Bus, and Enterprise Service Buses build systems by having services that communicate over a standardized message bus, and they have messages that they send to each other, and usually those messages are very strictly and well defined. These are used in all sorts of industries, in, for example, healthcare, the print industry. There are many advantages to this as well, but the need to standardize all the messages and agree how everything's going to talk up requires a lot of upfront analysis, and particularly in the fast-moving industry, you can end up in a situation where you never finish defining the system and starting to build it. So it's a good idea. There's lots of advantages, but it has this problem of how you get everything defined. So we took a slightly different approach with Busby. The first thing we did was structure applications as loosely coupled services. So take the idea of microservices and use the languages and persistence that are appropriate to the subtask. But then we also provide an easy-to-use messaging service between the applications, and that deals with things like notifications and also request response messaging. And so that doesn't spoil the idea of microservices by limiting it. We don't define what the messages should be, what the payload should be, just provide the mechanism for moving the messages around and providing the fan out and broadcasting of messages. And that messaging service we've coded it in nearly all of the currently used languages. So for example, JavaScript, TypeScript, Java, C#, C++, so the sort of languages that people might want to create services in. As well as that, we took a couple of other ideas that were around. We've implemented a centralized configuration and control system. This holds all the configuration for all the services centrally and also provides a versioning system for that, so that when you make any changes, you automatically up the version. You can always roll back. You can keep control over how you roll things out and what order you do it. And the last thing is we implemented a lot of the common services that you require in media systems. So for example, talking to transcoders, providing workflow and state engines, big data reporting, alarming, sending messages over things like email, moving media over different transport mechanisms, for example, FXP. So a lot of common services are already coded in, and you don't have to start with those, which you would have to if you just start with a blank sheet and start building a system. So this is the toolkit approach, perhaps. Just a quick look at the sort of the messaging idea before we get on to the system. So in this example, you've got this transcode service, and the transcode service in this case is provided by multiple providers. So this is fairly typical where you've got something that requires a lot of CPU load, for example, something that's transcoding video files from one format to another. You'd have multiple providers for a service. The other reason you might have multiple providers for a particular service is to provide redundancy. And the way you can group those is either in a all active, where you're sharing the load, so a load balancing kind of approach, or you can have them in an active standby approach, where you need a single source of truth. And that's all handled by the bus for us. So again, the utilities are there to handle all of that. Anything in the system can connect to a service, and then it can send messages to it and get messages from it. It can also, things can subscribe to notifications from a service, and they'll then get asynchronous notifications. And this is a typical kind of messaging structure here, where, for example, if there's a problem with the transcode service, it sends an alarm message to the alarm service latches the alarm, sounds the buzzer, and then it updates the alarm status to a web server, which is providing the user interface. So that's a kind of a flow through the system, a fairly typical one. And that's the messaging, which is a key part of how we build things. The other part of it is centralized configuration and service management. And I think we'll look at those in more detail now by looking at a real system. Excuse us while we shift things around on the screen a little bit. We'll first of all look at the user interface that the system has generated for a particular task. And the task we're going to look at is a compliance task. In case you're not aware, this is a fairly common task in a broadcast workflow. That is, content arrives at a facility and it has to be viewed and marked up, often for censorship or to check it complies with the broadcast regulations. And in some cases, one operations team might be doing this for multiple languages, multiple territories, and so on. For the purposes of this demonstration, we've just put together a fairly simple workflow to show how you would build something like this. If we look at the task that someone who's doing the compliance job would see here, there's a queue of jobs that are waiting for compliance. If we select one of them, we get an interface where we can see the video, and we can then add a frame accurate marker at a particular point and then mark the out code, and that creates the marker. At the end of the process, we can then either export to Vantage in this case, which would be a transcode farm used to stitch the content together based on some pre-built instructions, or in this case we've got export to Adobe Premiere, so we could take this into an edit for doing a more complex edit to, for example, remove swearing or to mask things. Again, this is just an example of a process. It's not a complete one or an actual one. If we look at this from the point of view of the board, what we'd call the board, these are the steps in this particular workflow, and the jobs are the boxes inside each one. And we can move things from one step to another in here, and the ones that are in green are the ones we're allowed to move it to. So from there, I can only move it to one of those two steps, for example. So that's the sort of overview of a workflow. Now we'll look at how we built that in the toolkit using the different microservices. So this is the configuration tool. And the configuration tool on the left, we have the different elements of the system. So we've got global system things at the top there. That's used, for example, so you can have a test system and a main system, and you can deploy to those different systems to check a workflow out before you implement it, or to check changes to a workflow. All the systems have alarms and alerts. This is to allow you to report on faults in the system. You can automatically send emails or report up to a network management system, or perform other actions when you get an alarm. The hosts are the machines that are running the system, and in this case these are all virtual machines, and that's the usual case now. They would be virtual machines, either full-scale virtual machines or containers. And then we have the services. I won't go into the services in detail here, but these are all the services that are running currently on the demo system. And then perhaps the most interesting part is to look at the workflows. So if we look at the workflow we just saw, so this is the same workflow but from the design point of view, and you can see how each of the boxes here is linked together to form the workflow. So for example, the reason we could only move from the compliance state, compliance markup in progress, we could only move to those states that there are lines to from that box. If we look at one of these boxes and then how it's set up here, in this case, there's an option also to put a script in here, and the script can be used to make a state decision. So for example, I might decide whenever I complete a compliance markup, I want to send an email. And in this case, I want to talk to the bus, so I type Busby dot. It then says, these are things you can do. And for example, I might want to send an email, so I'd click email, and then it'll give me the parameters that I need to do to send an email here. I need the to address and the from address and the body of the message. And I can pull anything out of the job that I want to as well. So as a job moves through the process, at any stage, more information can be added to the job, and that can then be used in subsequent stages. So you kind of have this idea of state. You can either build things that messages just go from service to service and something happens, or you can build things where, for example, a file arrives, then it's processed, then it moves to the idea of things moving through from one step to another. And both of those, or a combination of both of those, is how we normally would build a system. The scripting here is just used as a way of gluing the system together. So you can use scripts, or you can use other decision-making processes to glue things together. And you can use, on the left here, you'll see these different steps that you can insert. So for example, if I wanted to checksum the file as it was going through, I could add that block and put a line to it from a particular state. Maybe we do it on before we do the, okay. We can decide how we want to do that and just move things around. We also in here can define forms that need to be filled in at different points in the process. So in here I can use these different field types and create a form for someone to fill in at a different point in my workflow. And I can create different boards for viewing those. Quite commonly we'd create dashboards. So if we go back to the user interface, you might have a dashboard that would show you, for example, how many things are waiting to be processed, the rate that things have been transitioning. And you can either look at, on the left here, we're looking mainly at things that are to do with the workflow, and on the right here, we're looking at technical parameters. Most systems, these might be separated out into two dashboards. So you might have a technical dashboard for use by the engineers, and you might have a number of operational dashboards that show overall progress of things through the system. The idea here being that you're using the system to glue together all the other systems that you have, transcoders, editing farms, that sort of thing. You can monitor all the services in the system, and you can stop and start them and so on centrally again using this interface, which has the current state of all the services, whether they're running or not, and the version that they're running at. That's really what Busby is and how it goes together. Does anyone have any questions?
So far, we have no questions entered.
Okay. In which case, thank you for your time and have a good evening.
Yes, then I take quickly back your monitor. And I think we have still no questions. The participants say thank you as well. We thank you. If you are around in Las Vegas, pin us and we can make a meeting. Otherwise, if you are interested in the products of Squared Paper a bit more into detail, let us know in an email and we will arrange personal discussions and personal meetings with you. Thank you, everybody, and have a great evening. Thank you, Spencer and John, for your help and assistance with the webinar.
Good night.
Thank you. Bye-bye.
Bye-bye.